And we start here from the definition of degrees of freedom. Degrees of freedom is defined as the number of independent variables or coordinates which are required to define the position of the system in the space is called degrees of freedom. Or secondly, we can say that it is the number of coordinates which are required to describe a system in space configuration is known as degrees of freedom, as we know that particle in space can be represented with three axes, x-axis, y and z, and this is known as coordinate space or Cartesian space. Now if we have one particle, it will have 3 degrees of freedom, and if we have two particles, then it will have 6 degrees of freedom. But if we join these two particles by small distance, or as shown in the figure, then degrees of freedom will be reduced to 5. This means that we can reduce the degrees of freedom in our system by interaction of the particles. Now here we define and take the concept of phase space in statistical physics. First we define what is meant by phase space in statistical physics. We define two other spaces. One is the mu space and other is the gamma space, and we will finally distinguish between Cartesian space, which we have studied already, and the phase space we will study here. First we define what is meaning of phase space. So if we have n particles and state of the system is this, which is described by 3n position coordinates. Position coordinates are represented as q1, q2 up to q3n, and 3n momentum coordinates which are represented as p1, p2 up to p3 of n. Then this 6n dimensional space is called phase space. 3 means we are 3 independent motion of particles along x, y and z axis, and n means the number of total particles. So total n particles have 3 x, y and z positions, so we can represent them 3n position coordinates, and momentum of particle along x axis, y axis and z axis, 3 momentum coordinates, and number of particles is n, so 3n momentum coordinates. Now we can represent this as a point QIPI, and this represents the particular state of the system in phase space, and as these QI position and PI, the momentum coordinates depend upon the time, so we can write them as function of time here, and they can change with respect to time. So a point P, which is a function of position coordinates and momentum coordinates, and these momentum and position coordinates are a function of time. When plotted in diagram, we will get a trajectory in the phase space, which is shown here in the figure. So finally we conclude that phase space is the space which is defined by the two coordinates, one is the position and other is the momentum. So here we are in a position to distinguish between Cartesian space and phase space. What is the difference between Cartesian space and phase space? In Cartesian space, we have only one coordinate, which is the position, whereas in phase space, we have two coordinates. One is the position and second is the momentum. So if there are two coordinates in a space, position as well as momentum, then this forms the phase space. And if the space is described only by position, then it is called Cartesian space. To understand this, we consider example motion of a bead in a along x-axis. So this motion of bead is confined along one axis, so it has only 1 degree of freedom. But if we describe this motion of this bead in phase space, this is in Cartesian space, if we describe in phase space, then it will have 2 degrees of freedom. One is the position, which is represented by q, and other is the momentum coordinate. So there are two coordinates, therefore it will have 2 degrees of freedom. So phase space for the constant momentum and variable momentum means if momentum is constant with respect to time, then we will have a straight line and constant phase space will be formed. And as we know that momentum is time dependent, depends upon time and changing with respect to time, we will get a variable phase space and we will have a trajectory as shown in the figure. Similarly, if we consider a free particle, as bead was confined to move along a straight line, but if we have a free particle will have 6 degrees of freedom, 6 coordinates in phase space, 3 coordinates as position and 3 coordinates as momentum of particle. So total of 6 degrees of freedom. So to represent the position and momentum, we follow the representation as x vector or p vector, or we write in square brackets. So in future, in statistical mechanics, we will represent position coordinates and momentum coordinates with square brackets. These brackets shows that these are perpendicular to, these axes are perpendicular to each other. And now we come to the two different spaces. One is the mu space and gamma space, and we define first mu space. It is the space which is associated with a single molecule. It is associated with a single molecule is called mu space, and mu stands for the molecule. So it is called mu space or molecular space. And if we have a system of n molecules, suppose we have a gas in a container and there are n molecules in the container, then the phase space formed by these n molecules is called gamma space. That is why it is stands for gas. Gamma stands for the gas. Now, as we have seen that phase space give us the concept of phase line, which is drawn in the position and momentum coordinates. So we will see what is the importance of this phase line in statistical physics and how it is useful to find the macro values of the system using this concept. Importance of phase line. If we have a single particle and it is in now 3 position coordinates and 3 momentum coordinates, so it will have 6 degrees of freedom and it is in the mu space. In this mu space, we only put a 1 point in mu space to represent a particle. And suppose we have a gas in a container and it contains n molecules of a gas contained in a container. So this container will have 3 position coordinates of a particle, of all the particles, n particles, and 3 momentum coordinates of all the particles. We will have 6 n degrees of freedom for the n molecules of a gas, and this can be represented in a space which is called gamma space. Gamma stands for gas. So in this representation, whole of this gas system, can be represented by putting a single point gamma space, which gives us the point or state of a gas in this phase line. It means that whole of the gas in the container can be represented by a single point in this gamma space. Now for this gamma space, because momentum and position coordinates both are time dependent, so it will give us the variable phase line, which is shown in the figure. And this phase line give us important conclusions. Number one, we see that this phase line gives us the complete information about the thermodynamic system. This is the first and one advantage of the phase line. Statistical physics is related to the phase line. So it helps us to obtain the time average of the position and momentum from the phase line. So it is very important that we get the time average of position and momentum from the phase line because it is changing with respect to time. So we take the time averages to find the position and momentum using the phase line. Time average which is taken in the phase line, it can be taken across over a appropriate section of the phase line. And what is meant by appropriate section of phase line we will discuss in the next slide. Now how this phase line is helpful to calculate a certain macroscopic quantity. For example, taking the averages of the microscopic variables, how we can find the macroscopic properties. For example, we consider the pressure of an ideal gas, which is calculated using this formula. Here, mass of the particle, molecule, and the total number of molecules, length in the cubical box. And this quantity is important, which is the average root mean square of velocities along x-axis. So knowing this Cxi, root mean square velocities, time average of this velocity give us the pressure of a gas. So this time average can be found by phase line, and we can find the pressure of a gas, and this pressure is the macroscopic quantity. So it is useful to find the time averages of the microscopic quantities and relate them to the macroscopic quantities. So that is why we say that phase line is important in statistical physics, and gamma space is considered because mostly we consider the gas molecules which contains a gas container having n molecules. So gamma space is used. As I said that we will give the answer what is meant by the selection of, or saying that appropriate section of the phase line, because time average is taken only uh, over a appropriate section of phase line. So if we have a gas in a container and we have large number of molecules and these molecules are colliding all the time with each other with the container, and there are millions of these ions, and we consider the million of Coulomb ions in 1 second of all molecules on a certain part of the phase line. So this selection on a certain part of phase line and for 1 second give us the appropriate section of phase line. So this time average can also be obtained by another method which we call ensemble method, and we will next study what is meant by ensemble method, and finally we will differentiate between this normal time averaging method and ensemble time average method, and we will see that ensemble average method is much better than the time average method because there are many drawbacks in time average calculation method.